Finally, let's look at the class diagrams for the library system. We have drawn the sequence diagrams, and in the course of drawing these, we came up with a number of methods for the different classes, the constructors for the different classes, and the flow of method calls, right? So if you collect all the methods for a class and come up with the fields using the constructor and a few other things, we will be able to draw the class diagram. So let's first look at this slide, which shows every physical class that we came up with during the design stage, except user interface. That is not part of the business logic. So we decided not to show that here. The library class, member list, catalog, member and hold, and book. And finally, we have transaction here. Let me briefly go over these things. There are no real surprises. Library, member, hold, and book were in the conceptual class diagram. These were shown as pure relationships. There was a Boros class which disappeared. It was originally really a relationship with an attribute which we thought of as a conceptual class, and hold is retained. You can see the relationships between the various classes. Library maintains a member list and a catalog. It is a one-to-one relationship from library to member list and library to catalog. A member list maintains multiple members. A catalog maintains multiple books. We have a relationship between member and book, and that is the checkout. That information is, as you know, stored via fields. The due date for a book is stored as a field in book. Hold is relating member and book, obviously. A member can have multiple holds, a book can have multiple holds. So this is really, we know, a many-to-many relationship. Finally, we have the transaction class, and it is related to the book class because a transaction is created for issuing, returning, placing hold, and removing hold. Those are indicated by these four dotted arcs. A member can have multiple transactions. Now, our system is small and we don't have that many classes. We see 7 classes here. Then we can draw that on a piece of paper. At least I mean, assuming we don't show all the details of these classes. But if you have many classes, this is going to be a challenge. So you have to have some way of splitting up your class diagram across multiple pages, because a page cannot be that big. So what we have chosen to do here is show the names of the classes in most of these cases, but show the details of the individual classes in individual slides. So the library class is shown here, the class diagram for library, without really showing how it is related to the rest of the system. And these were obtained by collecting the methods of the various sequence diagrams given in the various sequence diagrams. And we know that the library has to maintain a member list and a catalog, so they are fields. A member has all these methods. Some of these were obtained from the sequence diagrams and some were simply getters and setters. Now, the constructor that we had in the add member sequence diagram was having name, address, and phone. So that is here. And those things are also fields. So from these three parameters, we can infer that the member object has to, or the member class has to have three fields, name, address, and phone. Then from the various sequence diagrams, we know that the member has to maintain the list of books the member has borrowed, the holds the member has placed, and the transactions. We choose not to have collection classes for these because that is going to just make things more complex, having too many classes for a class project. But if one wants, we can have these as well as collection classes if you want. Catalog, we gathered the methods from the sequence diagrams, and obviously it has to have some kind of a object to store the list of books. So we decided to have it as java.hot.list. This may or may not be the best choice for efficiency purposes, but we are keeping things quite simple in this class project. The book class, the methods were mainly gathered from the sequence diagram, but then we also have some getters here. The constructor is here, which, like the member class, suggests a few fields, and we need to have a list to store the holds, the member object that has borrowed a book, and the due date. Member list is very much like a catalog. We have three methods. We don't have the delete member functionality, so there is no such method. Whereas if you look here, we have for the catalog, we have a remove book. There is no such thing for a member. And we have to store the members. Again, we chose it as java.util.list. Hold has to store a reference to the corresponding member object and book object and the last date for which this hold is valid. Transaction, we talked about the fields for this, the type, the book title, and the date. These two fields, book title and type, have to be accessed by the user interface class, so that has to be, or though they have to be public. And there is one method here, on date, which given a calendar object, which is essentially a date, would, or you can think of it as a date, would say whether this transaction was on that date. So suppose this transaction had the date November 15, 2019. Then if you passed November 15, 2019 as a parameter, this would return true. Otherwise, if it is any other date, it would return false.